Hello and welcome back to Dr. Logic Awkwardly Does Logic in Her Kitchen. Here in this video, I'm going to go over the general definitions, a bit of refresher of vocabulary, notation, etc. for proof theory. Now, a lot of it's going to be very familiar. It's just going to be the same sorts of definitions that we had for propositional logic, because the whole point of making the definitions as broad and as general as we did was so that they could cover many different proof theories, including the one that we introduced for propositional logic, for predicate logic. So this should all be fairly straightforward. The first component that we have is the notion of a proof theory. So a proof theory, let's call it T. For a quantified language LQ, it's always going to consist in two parts, two components. The first one is a set of LQ formulas that are called axioms. Now, you'll remember that we had axioms in the proof theory for the syllogistic, but we didn't have any axioms for our propositional proof theory. It still makes sense to talk of having proof theories having two components, one of which is the set of axioms, even if that set happens to be empty. The second are the rules of inference. They are essentially rules that tell you how to take things already written down in your proof and turn them into new things. So for each rule of inference, we have essentially we have a relationship between some number of formulas, 1, 2, could even possibly be more, and then another formula. So you can think of conjunction introduction as a relationship between two formulas, the conjuncts, and a third formula, the conjunction that you introduce. So these are going to be, in our case, introduction and elimination rules for the propositional connectives, the quantifiers, and because we've said we're just assuming that we have identity in our language, we will have rules of inference specifically for identity. And then, of course, we have a notion of a proof in one of these proof theories. So here we go, another definition. A proof in some theory T is a finite sequence of well-formed formulas, phi 1 to phi n, such that, oh, what has gone wrong with I'm really having problems with my mouse, and this is not good. Such that every phi n, give me a moment, I'm going to stop sharing and then reshare, and let's see if this fixes things, because that did another time. Okay, let's see if this works. Such that every one of these phi n's is either an axiom or the result of correctly applying one of our rules of inference. Now, our rules of inference, for the most part, were designed so that they made reference to things that occurred earlier in our proof. Not all of them. Assumption, we can just write down without referencing any line earlier in the proof. However, for the most part, our rules of inference do rely us to kind of have something already written down. So I'm just going to add in as a bit of a parenthetical, the result of correctly applying one of our rules of inferences to something earlier in the proof. So if we have a proof from no assumptions, the notation for that is this single turnstile. We'll annotate it with T to say it's a proof in theory T, and then you write phi after that. If the proof has assumptions, say they are all the formulas in some set gamma, then we write gamma, so the set of our assumptions on the left-hand side, then the single turnstile, and then the phi. Now, when no ambiguity will result, because, for instance, we're only working in one proof theory, we won't always continually write the T underneath. We will just write the single turnstile. And I will wrap things up now because it sounds like there's tea being made in the background and I can't talk over that. Here's the basic definitions for proofs, and next time we will start looking at the rules. So join me then. Take care. Cheers.